Sus scrofa, the pig. A rather comic animal, with a digestive system curiously akin to man. An important part of a farmer's profit. A subject of study for the biologist and nutritionist. The housewife sees it like this, or this. In 20 years, consumption of pork in one form or another has risen 2.5 times, and it is still rising. An increase on this scale wasn't just a simple matter of producing a few breezy television commercials.
Only a mother knows it's sizzling, succulent pork sausage.
It was more radical than that. It was a process in which the farmer, the consumer, and our understanding of the science of nutrition, in human as well as animal terms, have all gained. The farmer had not only to raise more pigs for the market, he had to raise them faster. It meant the farming industry and the researcher working together on completely new methods of rearing and feeding. It involved a fresh examination of basic nutritional needs. The pig's natural diet is a combination of grass, seeds, and roots. Proper growth depends on the way the body breaks these down to provide the right balance of nutrients: proteins, carbohydrates, fats, minerals, and vitamins. In considering any efficient supplement to the diet, this is where the farmer must start. Take protein. Protein in food is broken down by the digestive processes into amino acids, which are later recombined in different forms to build new body tissues. There are 20 amino acids. Half of these the pig can synthesize itself. The other 10, known as essential amino acids, must be obtained from the diet. A shortage of any essential amino acid will lead to ill health or abnormal growth, or even stop growth altogether. Vitamins must also be present as catalysts for growth to take place. The pig has only a limited ability to synthesize vitamins such as vitamin C, so the rest must be supplied in the diet. Minerals, too, are essential for growth. Over 70%, mainly a combination of calcium and phosphorus, go to form bone structure. Other important elements include iron, magnesium, sodium, potassium, chlorine, and sulfur. Some minerals, manganese, iodine, zinc, and copper, are required only as traces, yet all are crucial to proper metabolism. The importance of these trace elements to health was emphasized as soon as the first attempts were made to increase production by modifying feeding methods. It had always been customary for piglets to stay with the sow until they were about 2 months old. So, with 4 months gestation and 2 months lactation, 6 months in all, the sow could only have 2 litters a year. If the piglets could be weaned earlier, the sow could be mated again earlier. But just how soon could the piglets be weaned? Not at birth. Pigs are born without natural resistance to disease. They get immunity from antibodies in the sow's milk, and for this they need at least 3 days. But could they accept a substitute diet after those first 3 days? Natural sow's milk was analyzed. The proportions of protein, fats, carbohydrates, minerals, and vitamins established, and then reproduced in a form the piglets could assimilate. In these first experiments, the substitute milk was composed mainly of glucose for energy and skim milk powder and herring meal to provide protein. During 3 years of trials, the formula was modified time and time again until, as it was thought, the right diet for early weaning had been established. But this was only the first stage, the laboratory stage, the observation of a problem, the formulation of a hypothesis, and the check under laboratory conditions. Now came the second stage of tests, on an experimental farm. On this wider scale, while still under controlled conditions, the diet was equally successful. Only at the third and final stage, the ordinary working farm, were the real problems revealed. It was difficult to keep such young piglets warm and free of infection, and far too much time was involved in sterilizing containers and mixing each fresh feed. Under ordinary farm conditions, weaning 3-day-old piglets simply wasn't a workable proposition. Then, after more investigation, it was found that by the time they were 10 days old, the piglets could manage dry food. The project immediately became much more practicable. But what about the economics? However good the new diet was, it couldn't be recommended unless the farmer could make a profit. When early weaned and normally weaned pigs were weighed at 8 weeks, the early weaners were heavier. They could be reared to market weight sooner, with a saving in feeding costs. And the sow was ready for mating earlier. The method worked well. The farmer's costs were reduced, and early weaning became generally accepted on farms throughout the country. Yet within 18 months, the whole system was seriously threatened. Because of its very success, the number of pigs rose rapidly. Overcrowding developed, hygiene suffered, and health deteriorated. Every aspect of the diet was questioned, trials organized and analyzed until the answer was eventually found. It was a question of bacteriological control. It was discovered that copper was the best means of controlling harmful bacteria in the gut, better than antibiotics, and without the tendency to produce bacterial resistance. There are still gaps in our knowledge of the precise functions of many mineral elements, but with an increase of copper in the diet, health improved at once. Of course, methods improved with practical experience. Weaning was put back from 10 days to 3 weeks, and to avoid overcrowding and disease, the young pigs were kept out of doors all the year round, a revolutionary change. But basically, the success of the new system of early weaning came from a correct understanding of nutritional needs. Advances like this in our understanding of the function of trace elements weren't confined to young piglets. Improvements in methods of management and feeding led to older pigs growing much faster. But faster growth itself brought its own problems. In particular, a skin condition. The pigs scratched, lost appetite and weight. Some of them died. It was a kind of dermatitis known as parakeratosis, which appeared in the form of black scabs. Investigation gradually eliminated one possibility after another. Something was missing from the diet. Eventually, after months of research, the addition of zinc to the diet brought dramatic results. The skin condition cleared within 2 weeks, and the pig once more returned to its rate of improved growth. The explanation was simple once it had been found. Before, when growth was slower, the piglet had had time to store up the necessary reserve of zinc in the body. But when the growth rate was improved, the reserve could no longer be built up adequately, and a deficiency resulted. We now know that zinc must be present in the right amount. It is essential to cell formation in a healthy skin. But trace elements and their functions are only one aspect of the subject. Every constituent of the diet must be studied in the search for better growth. High-protein foods like fish meal had long been known to produce faster growth. But fish meal had become too expensive for the farmer to use. A more economical substitute might be found, but first it was necessary to know why such a meal was better than other protein. By ion exchange column chromatography, different proteins were analyzed. A significant factor soon emerged. Fish meal contained a higher proportion of the essential amino acid lysine. Could synthetic lysine be added to lower value proteins to make them equally good? 4 different diets for young pigs were worked out. Each contained 16% protein, but the proportion of fish meal to lower value protein varied in each diet, so the lysine content decreased progressively. The pigs all started at the same stage of growth, but those fed most lysine grew the fastest. When synthetic lysine was added to the diets low in natural lysine, the pigs all grew at the same rate. The trials confirmed that the nutritional value of animal protein lay in the quantity of essential amino acids supplied. Amino acid requirements varied as the pigs grew, but at every stage of growth, an economic meal fortified with synthetic lysine could now be used. From applied research projects of this kind, as well as from fundamental research, our knowledge of nutritional requirements and the way they change at every stage of growth is constantly expanding. We now know more of the functions of trace elements, more of the part played by protein in nutrition than we did before. For each kind of research stimulates and nourishes the other. The farmer, the consumer, and the complex science of nutrition in human as well as animal terms have all gained.